Hey guys, good evening. I hope I'm pretty much audible as well as. Yeah, looks like we're pretty much good to go. Just a few minutes, guys, setting up a few things. Cool. Okay. So till now we have been discussing about a lot of important topics in data science. We have been discussing about all of these one by one. Now, today we are going to start in detail about machine learning. So we will be talking about some interesting topics in interesting parts of machine learning. So we will be going in detail for this, and that's pretty much what the agenda is. Hey Shubham, good evening. Hello Ajay, good evening. Just a minute, guys. Okay. So with this, I think we can start about our machine learning part. So today we will be prominently discussing about machine learning, and as you know, it's pretty much a live session. So if you have anything which you want to talk about, if you know anything in general, also we can always talk. So we already have that notion. So now let's get started towards machine learning. So before even proceeding towards machine learning, I'll just quickly introduce myself. So you know, my name is Arpit Jain, lead data scientist myself. The only reason I'm here because data science is what my true passion is, and I really like sharing my expertise with people. And technically, I have 10 plus years of industrial experience into multiple domains of data science. And I'm also pretty much a motivational speaker. So I do talk to students regarding job placements, career jobs, anything in general. Also, please feel free to reach out. We can always talk. Cool. So with this, I think let's get started. So our agenda is prominently towards machine learning. So machine learning, obviously there are a lot of buzzwords around, right? So we have been learning about we have been actually listening to something called as regression. So what is regression? We have understood some fancy terms such as decision trees, right? And we have been talking about random forest. So there are some fancy keywords which is part of my things here. So decision tree, random forest, and everything. So this is what we have to understand, like how we can use this part specifically. So regression, classification. Then there's something called as reinforcement learning as well. So again, very interesting topic. So reinforcement learning. So how does that happen? What is that? So again, an interesting topic. So all of this is pretty much part of my machine learning. So if you understand what machine learning is, it is not only about this technical term. There are a lot of keywords around this. So we talk about first, like why this is important. And even before that, we will be answering what is machine learning, right? And then we'll talk about certain applications of it. So where exactly we can apply this machine learning. So can we apply machine learning to our day-to-day activities? So what exactly machine learning is? What is that machine? How it is getting learned? What do we mean by all that? So again, applications, we will be purely discussing around that. And again, obviously, at the part of it, we'll be discussing about it types. So types of machine learning, broadly three types. So we have something called a supervised method. That is where we will be discussing the interesting names. Then we have unsupervised method. Again, we'll be discussing about some interesting names here, some methods. And again, here we will be talking about the last semi-supervised. That is exactly where the reinforcement learning comes. So all of this is what my agenda for today, guys. So we will be discussing about all of these interesting topics today. That's pretty much we will be going in detail. And as you know, it's pretty much a live session. Hey, Tejas, good evening. So please feel free to ask your doubts, guys. It's not about me like finishing up the topics. You can stop me in between as well, and I'm happy to answer your questions. Okay, so always feel comfortable in that part. So moving ahead, guys, let's try to first understand what is machine learning. Okay, so even before machine learning, we have to first understand what is artificial intelligence. Okay, so I have been talking about artificial intelligence a bit more. So let me just quickly reiterate what do we mean by artificial intelligence. So I'm just gonna pull up things here. So bigger umbrella is artificial intelligence, guys. So there's always a confusion. So what we think is like AI or artificial intelligence is something different and ML is something different. Okay, so it's not exactly the case, guys. Let me explain you what it is. So artificial intelligence is actually broadly divided into two types. Okay, first is strong AI and the second is weak AI. Strong AI is also called as artificial general intelligence or AGI, artificial general intelligence. So basically the core objective of strong AI is mimicking every activity what a human brain does. So my prime objective is I'm going to mimic all the activities what a human brain does. So I'm going to mimic all activities of human brain. Okay, that's pretty much what are we going to look at. So I'm going to mimic all the activities of my human brain. That is what AGI is, and that is the place where we talk about robotics. Okay, so robotics is purely falling under strong AI. I'm talking about mimicking all the activities what the human brain does, and this is obviously a part of research. Okay, so there are few organizations who are dedicatedly working in the robotics area, and their experiments are going on, researches are going on. This is a area of research. Okay, robotics. Now comes the second part, which is weak AI. So the prime objective of weak AI is solve one problem at a time. For example, so I know that I'm trying to detect cancer in my patients. So when I'm trying to do that job, I'm only doing this detection of cancer in patients. I cannot do anything else. I cannot ask the machine to go and find out what will be the score of any match tomorrow. No, it is only going to solve only that job, which is finding out or predicting the or detecting the cancer among the patients. Okay, so that is where I'm only concerned with one single objective, and that is the place where machine learning comes into picture. So machine learning is pretty much falling under weak AI, okay, or we also call this as narrow AI. Okay, that is where my objective is to solve only one problem at a time. Okay, under machine learning, yes, we have certain types. That's what we have been discussing. Also, deep learning is further sub part of machine learning itself. So machine learning itself has another sub part, which is deep learning. This is more like advanced algorithms. But again, these are set of algorithms only, certain set of rules, protocols, pretty much falling inside my machine learning part only. Okay, so if I have to quickly summarize all this, whatever we have learned so far, so let me do that. So I can simply say this, we have a bigger umbrella. Okay, very bad drawing. So this is called as artificial intelligence. Then we have a smaller circle inside this. We call this as machine learning. And then we have even smaller circle inside this. We call this as deep learning. So AI basically has one of its subdivisions as machine learning, And machine learning, it has one of the subdivisions as deep learning. That's how the hierarchy of things are, guys. So that's how we have to identify what is artificial intelligence, what is machine learning, what is deep learning. Okay. So artificial intelligence and machine learning are not different. They're basically the same thing. I'm talking about solving one single problem of any learning process. That is where I'm trying to do it with certain set of rules, protocols, which is called as machine learning. Okay. Now, with this, coming back to my original slide, which was talking about the same thing. So machine learning includes a section of AI, and deep learning is part of my machine learning. I hope this sentence makes sense to everybody now, right? So machine learning, it's basically one of the subsections of artificial intelligence, and deep learning is one of the parts of machine learning. Okay. So here, objective is to learn the data and give some meaningful business outcomes. What do we mean by that? So basically, I'm trying to let the machine understand and learn something, right? So when I say I want to detect the cancer among the patients, so if I go to a doctor or any disease, right? So if I go to a doctor, what does a doctor ask, right? Certain symptoms, certain reports, right? So when the combination of certain reports, certain symptoms, okay, by correlations, by finally seeing all those numbers and all those details, doctor is able to come to a conclusion saying that yes, you have this disease or you don't have this disease. So I'm trying to find out certain patterns. Being a doctor now, I've studied so much and I'm able to relate all those different things and ultimately coming to a conclusion with that, right? So that is where again a learning comes into picture, but that is a human brain. So human brain has learned with time. Similar thing, I can let the machine also learn, but for the machine to learn things, again, I have to provide some data to that, right? And that is where I will be asking machine to see all the similar patterns for some other patients in the history, in the past, and learn the patterns, learn the trends, which ultimately correlates to this outcome, whether the person has this disease or not. So whatever meaningful business outcome is, whether I'm detecting a disease or whether I'm predicting the churn or default or anything, I'm trying to make the machine learn about that objective. Okay. So end thing is I'm trying to let the machine see those patterns and understand how things would be. Okay. So here the main thing is machine learning includes the pattern recognition. It is very important. So machine is learning the pattern recognition. So basically it's the ability to recognize the patterns in the data and ultimately come to a conclusion. Okay. That's pretty much what machine learning is, guys. And now it's very important to understand why do we do machine learning? So why it is so overhyped? Why exactly it is even important? Why are we doing this machine learning? So we have understood the basic part, like where I say that, okay, machine learning is where I have certain set of data, certain set of information already available. Now on top of that, I'm trying to let the machine learn something. I'm trying to let the machine see what are the patterns, and accordingly based on that, how the output should look like. Correct? So the question here is why it is important when I know that a doctor can actually do that job, right? So why exactly I would need a machine to do that? So technically, let's try to understand why are we doing it. Obviously, theoretically, what we can see is we are automating something. We are trying to do something what a machine, what a human can do without having the presence of human as well. So I'm trying to do those tasks which might be helpful in case of automation, in case of replication of those activities where a human mind is needed, right? So it's more like machine learning is exploring the analysis and construction of algorithms that can learn from and make predictions on the data. So it becomes very important to let the algorithm learn and make the prediction. When I say algorithm are nothing but set of protocols or set of rules. Okay, so that is basically how and why machine learning is helping to learn certain patterns. Okay, And ML has proven valuable because it can solve problems at a speed and a scale that cannot be duplicated by human mind alone. Very important point, guys. Let's try to understand this. So when I say I'm reading all those reports, being a doctor, and I'm seeing all those symptoms, and I was talking to a patient, and ultimately coming to a conclusion. This process takes what? Minimum 10 minutes, right? Minimum 10 minutes is what it takes. Imagine in those 10 minutes, I can predict, I can detect the similar disease for 10,000 more patients. Do you think single human brain can do that? Impossible, right? Now, that is a task where I can replicate the similar activities for tens and thousands of more samples if we want in that say. That is where it has become more valuable, because I can replicate the similar things at a lightning speed and on enormous scale, which a human brain alone cannot do. Right? So obviously we need to make sure that we are able to do the task in a much more efficient way, automated way for bigger population. That's where again it becomes very important. And also, even before that, you need to understand one thing. When we talk about this activity where the machine learning is able to solve the things on a lightning speed and then definitely on a scale job, how the learning process has happened. So imagine now I'm saying that the doctor is able to tell you whether, seeing the symptoms in the reports, whether the person is having the disease or not. He definitely has learned in the background, and based on that, the learning is actually helping. Think about now, I'm not only asking the doctor to learn about 10 disease, I'm asking him to learn about 10,000 of disease. Think about the complexity which it will arise, right? You think it is practically possible for a human to basically adapt or learn all those complex things alone? It becomes very, very tedious and very more like an impossible task, right? So I can, in the machine learning process, when I'm asking machine to learn this, I can make this process as complicated as possible. I can give the machine enormous different patterns. I can ask the machine to learn it, right? So that is again one of the very important aspects of machine learning, where I can increase the complexity of my learning process, which a human brain cannot do. It will be difficult for a human brain to replicate that part. So again, one of the very core reason why machine learning becomes important, guys. So two things here. Obviously, when I talk about machine learning, the things, there are two key aspects to that. First is data. So obviously for a human brain also, we need something to learn about. Even for the machine, it is very important to have the right data. So the algorithms that drive machine learning are critical to success. Any algorithms that is driving the machine learning are critical to success for me. And ML algorithms build a mathematical model based on sample data known as training data to make predictions without being explicitly programmed to do so. Very important, guys. See, again, understand one thing. I'm trying to let the machine learn something, right? So to have the machine those capabilities, to have the machine learn those things, I need to provide those information to the machine, right? So data becomes very crucial in terms of success of this ML algorithms drive, right? So it becomes very important, that part. And ML algorithms is actually building up that mathematical model, which is actually finding out the right patterns across all the data points and then giving us the result. So the data which is actually technically fed to the machine or to the algorithm on which the training, the learning happens, is called as training data. So technically we have a term for that. So all those data points, all those information which is actually getting used at the time of learning process is technically called as training data. Okay. And ultimately, at the end, AI is our goal. So ML does provide the foundation for any AI systems to automate the entire process. And ultimately, it should solve the problem autonomously. For example, suppose I say detecting the cancer of the or detecting any disease in the patients. I would want this to be automated. The moment we have this information, it should be done. I'm not supposed to book an appointment with a doctor. As soon as it gets detected, I should be able to get a pop-up saying that yes, I might have this disease. It's an automated process, right? It's running in the business. Like way, I say that I'm running an e-commerce business, I'm running a telecom business, and there's a high probability that my customer is going to move out of my service. So even before they move out, I should be knowing as my as a business leader that okay, this person is having the highest probability of moving out, and it's an automated process. I'm not asking the machine to learn. I'm not asking the learning process to happen again and again. Once the machine has learned it, it should be able to automatically detect those people without me explicitly calling the systems again and again, just making the entire process autonomous, self-driven business solution, right? So this is again very important key part in for any AI related problem statement. That's what we solve. So two things: data is the primary key here, where we talk about the right information critical to success. Training data, that's what we talk about. And then ultimately the AI is the goal, which is my autonomous self driven autonomous problem solving process, right? So that's pretty much why it becomes important. Cool, guys. Any questions, please let me know. Happy to answer that. So meanwhile, applications. So obviously, if you in fact, if you see around you also, right, you will be seeing you are actually surrounded by the applications of machine learning. I've listed down few very basic examples, crude examples, but very layman term, if I have to say, simple thing. Everybody watches Netflix, everybody sees some of the other OTT platform, right? So there's a small section called as recommended for you, right? And in fact, similar thing happens on any platform you visit for shopping or e-commerce website, right? You'll see recommended for you, right? So how the hell they know what is the recommendation, what is the right recommendation for me, right? How does the machine know? How does the website knows this, right? So that is again, there is some learning happening in the background. There's some smart people like us sitting in the background doing all this training mechanism, learning. When I'm talking about the training data, right? So all the learning process is happening in the background. Some smart people is doing that. And then ultimately, the result of that you are seeing on your screen. Not only this, if you go anywhere, you will actually find some really smart applications of machine learning. I'll give you a very simple example. You go to supermarket. So generally, if you would have realized, everything is so properly stacked up in the aisles. If I'm buying milk, I know that I'll be finding bread nearby. I might not have something else, maybe something else, and which is not even relevant to my morning breakfast there. So how the things are getting arranged so properly, we call this as a market basket analysis. Very, very interesting use case where how to place up the objects nearby so that it has the maximum probability to get sold, again plays a very crucial role here. I'll tell you a very interesting example about market basket analysis. I was reading somewhere some time back in one of the papers. One of the European supermarkets, they have tried this, obviously based on the machine learning method. They've started keeping baby diapers near the milk packets. And interestingly, they have increased the sales of that baby diapers. I mean, how they would have related this and how the machine has actually identified the correlation between a diaper being sold along with the milk, that's surprising, right? So all of these fancy things which you see around you, you're pretty much surrounded by machine learning applications every day in and day out. Let me read out a few of them. Data security. So yes, it is going to predict the high risk activities so that we can mitigate that part in future without even the breach being happening. I can let the machine learn about the past experiences, and then based on that, the machine can actually predict about the high risk activities in future, and I can obviously take a preventive action even before a mishap has happened. Finance, banking, trading brokerages firms, or any fintech firms, they actually use the machine learning methods to automate their advisory systems. For example, stock market. I know that stock market, if my trend of my stock is something like, say, this, I have a stock market, I have a stock, and in the past trend, I'm seeing that the values are increasing like this. So it is expected that nth time in future, which is here, the value will be somewhere around this. So this will be my value based on the past trend, right? So again, all of this is pretty much part of my machine learning itself, forecasting problem. We talk about finding out the risk elements, so fraud detection, churn detection, right? So giving it the right percentage of loans, right? Or identifying the right brokerage amount. So all of this is pretty much an activity of some or the other way for machine learning here. So again, in finance industries as well, it finds a very crucial and important part. We move towards healthcare. So we have been already discussing about healthcare in our examples. So massive healthcare data sets, it definitely helps us understand and discover the treatment as well as the cures of the patient very well, right? So it definitely prevents the human errors lot many times, because machines cannot lie. Whatever it has seen as a trend, it will give you the output plain, as simple as that. So it does prevent us avoiding any last moment human errors, and it does help us to read those advanced complex patterns available across my multiple data information, and then based on that helping to take the right decision, or helping us to discover or diagnose the disease at the right time so that the cure can be done effectively. Again, healthcare industry, it definitely finds is very much of its usefulness. And in fact, now the healthcare industries, they are very prominently using healthcare machine learning related products, so that ultimately it is going to benefit the humankind, right? So yes, there's a lot of applications of machine learning in healthcare industry. Then we talk about fraud detection, right? So identifying any fraudulent transactions, right? So it is very untidy or impossible to detect the fraud in like billions and trillions of transactions happening every day. For a human to identify a fraud transaction manually, it is like next to impossible, right? So identifying the fraudulent transaction, that too in the real time, that is where again machine learning plays a very crucial role. There's a lot of detection based activities, classification based activities going on, which definitely helps to detect the fraud at the right time, right? Then retail, I talk about the recommendations, so giving you the right choices, which might help you to go for the right product depending on your regional information, your demographics, your geographical information. So all of your past historical data, your information based on your data, I am suggesting you, being a machine, like what would be the right choice, just enhancing my experience, giving the user a personalized touch, right? My recommendation will not be visible to some other user. It is only applicable for me, not for anybody else. So those activities does help to boost up our sales. So again, so by now you would have realized that actually data science or machine learning is so diverse that it finds its usage almost every single place. I can actually learn data science, or I can actually use machine learning to solve practically any business problem in any domain, be it healthcare, finance, telecommunication. I talk about logistics, supply chain. You just name the field. The data is everywhere. The moment we have any sort of data science or machine learning finds its usage there, right? So moving ahead, practically, as I was saying, machine learning is of three types. We talk about supervised mechanisms, unsupervised mechanism, and semi-supervised mechanism, right? So we will be discussing about these three one by one. So first, starting with the supervised learning. So supervised learning is pretty much one thing we have to always remember this. There's something called as target or something called as label. For example, I will take the same use case like I'm detecting, say, disease in the patients, right? So when the doctor was also learning in its learning time in the medical college, so even at that time, the doctor knew, okay, for disease A, these are the symptoms. These are the numbers for all the important vitals, right? For disease B, these are the symptoms. So I know, okay, this set of symptoms, this set of vital values resulted in this disease. So the disease is basically the label for me or the target for me, because based on all of these symptoms, it is resulting in the final target, final output, which is the disease A, right? So all those method, all those training cases, all those problem statements where I do have the labels, apart from having the data, the features, I also have the label. I know that, okay, now this set of features corresponds to this target. That is where the mechanism is called as supervised learning mechanism. As a name also suggests, supervised. I'm supervising something. I'm under the supervision of something. And what is that supervision? I know that, okay, this set of features results in this output. Okay. And the main objective of any supervised learning mechanism is basically to find the relationship, the association, to learn that association between the set of input data points and its corresponding output. So I know that symptom 1, symptom 2, symptom 3, symptom 4, symptom 5 results in disease A. I know symptoms 1, symptom 3, symptom 10, symptom 11, it results in disease B. So I should have that relationship, and the machine should also learn that association. And that is what the main objective of any supervised learning mechanism comes. So broadly, there are two types of learning methods, two types of supervised learning methods. So let me just pull this here just a minute. Yeah. So broadly, there are two types of learning methods, supervised learning methods. First is called as classification. Second is called as regression. Okay. So what is a classification problem? They both comes under supervised method. So classification is where the target or the label is in form of a class. Like when I say the person is having the disease or not. So disease, yes or no, 1 or 0, or like yes or no, or true or false. So whether this person will churn, whether this is a fraudulent transaction, yes or no. So all those type of problems where I have an output or a label in terms of a class like 0, 1 and whatnot is called as the classification problem. And then we have the regression problem, the regression where the output is in terms of a continuous number. Where I say, instead of predicting the class, I'll be saying, what is the potential salary of this employee? What will be the potential price of this house? So I'm talking about a random number. I'm talking about a continuous number, which could be anything between minus infinity to plus infinity. So any where the output is basically a regressed number or a continuous number is termed as regression problem. Okay. That is where regression comes into picture. So both the things, classification as well as regression, they both are equally important. Okay, and they both falls under supervised learning methods. Now under these, classification and regression, that is where we have all the fancy algorithms coming into picture. So all the things whatever you have been hearing so far, like decision trees, random forest, knife base, we talk about SVM, we talk about so many different algorithms are there, like, so all of these are pretty much coming under these categories only. So we will be learning about these also one by one in detail with time. Second method is unsupervised learning. Again, very important broad subdivision of my data science problem here. So in machine learning, then now next we talk about prominently into unsupervised methods. So unsupervised methods, that's where first we have to understand this is the place where I do not have labels. So I have no labels or no target. And as the name also suggests, it is basically that learning which is actually opposite to a supervised ML method. I do not have any supervision. I'm basically learning in an unsupervised way. I do not have any supervision of any sort, right? So there's no guidance available. When I'm saying this, I'm saying that ultimately I do not have any label. So I do not know what would be the potential relationship between an input and the output variable. So here the main objective of unsupervised learning algorithm becomes to find the interesting patterns from the available input data without any target variable. When I say, for example, similar example, I have a well group of 100 people available with me, right? And all of these 100 people will have certain likes, dislikes, they are falling to some age category. I mean, they have their own personal traits, right? But based on their traits like personality information or their geographical data or whatnot, any sort of their demographic information, I'm trying to group them into broadly 4 groups. I want to create 4 groups of people. From this pool of 100 who have some sort of similar likes, dislikes, obviously some sort of similarity I would need to find so that I can group them into 5 or 4 different groups of such sort. That is the kind of problem statement where it prominently talks about unsupervised method. So now I'm saying that I don't know what is the target here. I don't know what is the group number for each of these different people. What I know is basically one thing. I'm going to talk about their similarity. That's it. I'm just only going to look at how they both are similar. That is what I'm going to look at. And with this, prominently we talk how exactly we can find out these groups. Okay. And that is where again this part comes into very handy, very important. That's where we're trying to understand now, without even having any supervision, how we can find that. So that is where the algorithms unsupervised learning method comes into picture. So there are broadly 2 categories of jobs which these unsupervised learning methods do. First is clustering or grouping of sort. That's where I said that, okay, 4 groups or 5 groups or 10 groups, whatnot. Clustering techniques, that's where one of the core objectives of unsupervised methods comes. So, and the algorithms such as KNN, K nearest neighbors, K means clustering, all of this is pretty much part of my unsupervised method. Another, association. So we have been talking about market basket analytics. As I said, place bread with milk. So I'm trying to associate, trying to find the similarities between 2 different products, like the way Netflix also recommendations, right? So all those recommendations, how it is coming up, I'm trying to find the similarity between two products, trying to find the similarity between the product and the user, and ultimately combination of all these results is giving me a personalized recommendation. How it is happening, how the maths works behind this, we'll discuss about all that. And that is where again another objective of association comes into picture, recommendations. Okay, again very broad category of machine learning problem statements. Again, you will be seeing the application of it in your everyday life. Another method, unsupervised. Last is where we have the semi-supervised learning comes into picture. We call this as reinforcement learning. So this is more like a award-based learning. So I have predicted something, and now what happens, the machine tries to see whether this prediction is good or not. If it is good, obviously it's a +1 reward, something of that sort. If it is not good, if it is incorrect prediction, the machine penalizes the model which has learned, and the retraining process, or more like relearning process, happens as soon as I get a negative reward. So it's more like for every prediction, there's a feedback mechanism, there's a reinforcement learning which is happening in terms of every single trial. So what happens here is we talk about trial error and we talk about the rewards. There are two things. We talk about trials, we talk about rewards. So for each of my trials, for each of my experiments, the machine tries to see how good my predictions are, right? And then ultimately based on that, we try to give the rewards, reward as in plus, positive rewards for a good prediction, negative rewards for a bad prediction. And that feedback goes back into my system, and the machine tries to readjust the mathematical whatever parameters we have. We'll discuss that in detail. And ultimately that learning is where the reinforcement comes into picture. So in simple terms, is nothing but a simple reward feedback reinforcement signal, where whatever my process is, it is trying to learn which action is the best. If I go from step 1 to step 2, or if I go from step 1 to step 3, where is the best optimized results I'll be getting. So that is where again reinforcement learning comes into picture. That is what my reinforcement learning is. We'll be again covering this in detail, like how exactly the mechanism works about for the semi-supervised method. But again, one of the very interesting subdivision of my machine learning process. At last, we will be talking about challenges. Again, machine learning is never perfect. Never assume that is the perfect thing. We have challenges. Obviously, we have certain shortcomings in machine learning as well. First thing is, it is never based on a knowledge. It is purely based on data, right? So there is no human intelligence behind this. Whatever you feed, you're gonna get the similar output. We are not going to get anything else apart from this. Okay, so it is purely not based on any knowledge. It is purely based on what data is being fed for the training process. Very important thing to understand this. So it is never dependent on any knowledge. It is purely dependent on the data which is given. So there's no human understanding or human logical reasoning happening here. Second, very difficult to train. It sometimes becomes impossible to train on the available set of informations we have, right? So we always talk about how this thing would help us. So we always say that whatever data points we have, how we can get that sorted. So it might be it might be a situation that we don't have the right set of information, we don't have the right set of patterns which correlates with the output. We might not have the right infrastructure, we might not have the right capabilities. There are many difficulties in terms of training of my data set. Again, very core challenge of my machine learning. And since it is very much dependent on data and there is no human brain activity or human activity is happening around here, it is very much prone to data issues. If I have problems in my data, if my data is not a true representation of what I'm trying to solve, obviously I will be having absurd results. right? It is very prone to data which is given for the training process, and that is the reason why it is often very much biased, right? So whatever you give, ultimately that is what you're going to get, right? It's always important to understand how we can handle, how we can have the what to say, middle ground for all of this. So that's again what I intended to cover today, guys, prominently towards my machine learning part. So we discussed about how we can use all of these things one by one, and prominently we discussed about the different types, different mechanisms, and all that. So with this, guys, we have finished what I intended to cover today. I'm pretty much open to any questions if you have, or if not, then we can wrap it up. Cool, guys. So with this, I think we are good. Even if you have anything, I'm always available, so we can always discuss on our parts. But this is what I intended to cover, guys. Thank you so much for being patient, listening to me. I'll come again in the next class where we'll talk about some another interesting topic, guys. So see you in the next one. Thank you so much.